Hi everyone. We are discussing on the subject electromagnetic theory. Under that, we are discussing on the topic magnetostatics. So, in that magnetostatics, the last and final topic we are discussing now, that is inductance. So, and applications, and the third part is nothing but energy stored and energy density in a magnetic field. Actually, this inductance is a very large volume, so that is why I have divided this inductance into three parts. So the first part, if in my previous videos, the first part, the inductance first part, whatever I discussed is nothing but inductance definition and different types of inductance, that is self inductance and mutual inductance, okay, and some important points to remember. And the second part of that inductance video is about applications of inductance. Now the third part, so this third part is nothing but energy stored and energy density in a magnetic field. We are going to discuss in this video. So in this video, a simple way to understand and to find out the energy stored and energy density of a magnetic field. So, hi, I'm Nageshwari, Assistant Professor, Department of EEE, RMK College of Engineering and Technology. Now, the first one we are going to see is nothing but energy stored in magnetic field. When a current through an inductor is increased from 0 to 1 with the potential difference across the inductor is V, then energy supplied by the sources in time dt is given by. That means very simple. So whatever I discussed in wordings is nothing but when a current through this coil, okay, a current through this coil or through an inductor is increased from one value to other value means, then what about the potential difference across that? So the potential difference is across that is proportional to the rate of change of current with respect to time. So that only I have mentioned as like this wordings. So this wordings is it is very simple wording only. That is nothing but a potential difference. The EMF induced is proportional to the rate of change of time. So that is only explained. So therefore, so that is given by what? Energy. Okay, that the combined together is nothing but what? It is nothing but the energy. So therefore, the energy supplied by the source in time is given by dW is equal to VI dt. Okay, dW is equal to VI dt. So energy stored in magnetic field is given by, now what we need to do is, so we need to find out the W, and if we need to integrate it with respect to some value. So check, let me check the value is some 0 to 1. Okay, let us assume the value is between 0 to 1. So therefore W is equal to integration of 0 to 1 VI into dt. So now which is equal to what? This one is, we can say, we know very well what is V. According to the Faraday's law or according to the self inductance, so we know that V is equal to, so V is equal to L into di divided by dt. So V is equal to L into di divided by dt according to inductance formula, self inductance formula. We know that V is equal to di by dt only, no. So now what you need to do is you need to substitute this V in this equation. So therefore L into di by dt into I into dt. Now what is the final expression? That means the next expression. So the next expression is nothing but the integration of 0 to 1 into I. Okay, so 0 to 1 into I dt. So 0 to 1 into I dt. So therefore, what you need to do? You need to integrate this with respect to I only. So therefore, and you need to integrate it. So then what is your final answer? The final answer is nothing but W is equal to L into I square by 2. Okay, so what is that? We can express as W is equal to half Li square. So this is called as the energy stored. This is nothing but the energy stored in the magnetic field. Okay, this is called as the energy stored in the magnetic field. Okay, so what is energy stored? So I repeat once again, it is a very simple expression. So what is that energy stored? So the energy stored is nothing but the energy supplied by the source with respect to time is given by dw is equal to vi dt. Now you need to find out the w. So assume it is the current through an inductor is increased from 0 to 1. So therefore 0 to 1 vi dt. Now what is V? According to the self-inductance formula, so V is equal to L into di by dt. Now substitute that substitute that V in that expression. Then again you need to integrate that with respect to di. Then finally your expression for energy stored in magnetic field is given by W is equal to half Li square. Now the second part. The second part is nothing but energy density in magnetic field. So density. So density is nothing but energy stored per unit volume, we can say, is nothing but the density. Okay, so density is nothing but some surface, or we can say, okay, so some energy stored, or we can say, so energy stored per unit volume. So in general, what is density is nothing but what? So some surface, okay, per unit area, or charge per unit area, we can say. Okay, so with respect to electric field means what we can say, what is density? In general, the density definition is nothing but the meaning of density is nothing but some charge per unit length with respect to path means, or with respect to surface means some charge per unit area, or with respect to some volume means charge per unit volume. So like that we can define, right? Okay, here also we can define what is energy density. So energy density is nothing but some energy stored per unit volume, we can say. It is nothing but the energy density. Okay, so now we need to see here the energy density in the magnetic field. So from that we are going to see. So in that we need to start from the energy stored equation only. Okay, so what is energy stored equation? W is equal to half Li square. Okay, so now here what I can take, I can consider an inductance of a solenoid as an example. So in my part 2 video I have discussed this application also. So if you have any doubt, you can check it the part 2 video, okay, of this inductance. So what is the, from that expression only we are going to derive this energy density equation. Now what is the energy inductance of a solenoid is given by L is equal to mu naught n square A by L. Okay, mu naught n square A by L. Now what you need to do, substitute this L in the energy stored expression. What is energy stored expression? So W is equal to half Li square only, no? Okay, so instead of L you substitute here. Okay, so then finally what is your answer? W is equal to half mu naught. So I can replace this. Okay, I can replace this as like this. So such that I can divide and multiply L. Okay, I can divide and multiply. See, I need to get some expression. So for that I can do I can do any way. So here what I did is I divide and I multiplied L. Okay, in this expression, the simple thing. So if I divide and multiply L in this expression means, then what will happen is, so this will come actually. Ni by L, the whole square term will come actually. Now, what is that Ni by L? You all know very well the Ni by L is nothing but H, magnetic field intensity, mmf per unit length. That is nothing but what? H. So, you all know that what is H? Magnetic field intensity is given by the expression, so mmf per unit length. Okay, mmf per unit length. So instead of this, what I can write? So I can write it as W is equal to mu naught into H square into L into A. Now what is this L into A? Come on, what is this L into A? This L into A is nothing but what? Volume only. This L into A is nothing but what? Volume only. So therefore, so we know that again from the last expression only, again I repeated this expression. So W is equal to half mu naught H square into LA only, no? Okay, now what is energy density? So I told you in the beginning itself, the energy density is nothing but what? Energy stored per unit volume. So therefore, I can say W is equal to half mu naught into H square. Okay, since volume is nothing but LA only, no? So therefore, energy density, okay, so energy density is nothing but, so W is equal to half. So I can write it as like this. That means, so energy density, okay, so energy density, okay, so energy density is equal to, so energy stored per unit volume. Okay, energy stored per unit volume, or daily I can write. Okay, so energy stored per unit volume is nothing but the energy density. So therefore, what I can say, half into mu naught into H square. Now H square also I can divide it as H into H. Now what is this mu naught into H? Is nothing but B only, no? So that mu naught is into H is nothing but what? B only, no? So therefore, magnetic energy density is nothing but, so magnetic energy density also I can express in terms of W. So therefore, W is equal to half into BH. So this is called as the magnetic density, energy density. So the energy stored in the magnetic field, magnetostatic field is given by W is equal to integration of W into dV, or I can say W is equal to half into integration of BH into dV, or half into integration of mu H square into dV. So this is about, then finally what I can say, so W is equal to half into integration of mu into H square into dV. Okay, this is again the energy stored. From this I can express as an energy stored also, or I can say energy density. Finally, W is equal to half into B into H. So like this also I can express. Okay, so W is equal to half into B into H. So therefore, here in this video we have discussed two things. One is nothing but the energy stored. So energy stored is nothing but half Li square. So W is equal to half Li square. So half Li square. So this is nothing but the energy stored, and next one is nothing but the energy density. Okay, so energy density. So energy density is given by the expression, so energy density is nothing but energy stored per unit volume. Okay, energy stored per unit volume is given by the expression, so half into B into H. Okay, so half into B into H. So this is called as the energy density. So these are the two topics we have discussed in this video. Thank you all.